What is an example of software that you think gives the students control and helps bring back some of that interest in what they're doing?
Well, the one I use is geometer sketchpad. It's truly for me the most amazing piece of software because it can be used in a variety of ways. When it's a group of students that struggle with math concepts but aren't the ones that are highly motivated, I can turn that into a nice directive activity.
How do you know what the students are learning when they're using software like that? How do you assess them?
Yeah, a couple of ways. One is you become accountable to the computer time or the calculator time. I think that's the other misnomer about heading down to the lab is sometimes it's the fun day and when we get back we have to reteach everything because we had problems with the mice and the kids weren't listening and some weren't participating. There's got to be accountability to the learning, and so after we've had that kind of experience we come back, there's a debrief session.
So you're tailoring what you do to their learning style. Have you seen students' learning styles and expectations and abilities change in the time that you've been teaching?
I do. Every student has their way that they prefer. There are students who would want me to lecture every day and tell them exactly what to do. And generally, unfortunately, in a math system, that's what most students experience. So by the time they've hit me in high school, that's what they expect math to be like. When I open the environment, and like we did today, and I say, you step into the darkness and solve it on your own, there is a fear issue there.
It sounds like you're using technology in ways that allow students to show what they've learned in a wide variety of ways, in addition to solutions to problems.
Yeah, certainly the typical math environment is I'm going to give you tests and quizzes and homework. And the traditional model of those items, I guess also over the years I've heard I don't do well on tests and I have test anxiety and I know it but I can't do it, or I knew it but I didn't know how to get it onto the paper. And initially my thoughts on those students was about a studying or a preparation issue, and since I've heard that many years over and over and seen those students and know they're good students, I've started to see that as a valid issue. They showed me steps, but maybe you're just creating a pattern of things that you just rotely do. When it's technology and the question is more about why and how, you actually have to know the concepts to apply them. And it's easy to walk and to watch students who can take the concrete and say, how does that apply? And if you can apply it, then you understand that concept. So we do projects, you see on the walls, we do a number of different things to display math in different ways.
When we were watching some of the students with their geometric constructions today, we saw that they found a solution and then they were having to explain it.
Right.
And we asked them what was the most difficult part for them, working through the problem or explaining and putting it into words. And the ones that we spoke with agreed that it was the explanation that was the most difficult.
And to me, that's what I value the most, is mathematics is a form of communication. Why a lot of teachers avoid geometry in particular is it's heavily based on communication. Most of the year is spent in proving things to be true. You know it's true, it makes visual sense it's true, but can you communicate to me that this is this because of a number of logical steps?
Areas and equal areas to a more complex problem is that when we draw one median in, we get two triangles of equal area. When we draw the second median in, it also splits our into two equal areaed triangles. The third line, as these two have said, finally also splits in this direction. I'm not going to tell you how to do the next question. When I come to your computers and you ask me, am I right? I will say, it looks good. Did it work? I'm not going to verify that you're right, you're wrong. The way you'll verify your ideas is to test them. What you will do is create a quadrilateral in sketchpad. You will then use what you've just learned, medians, midpoints, equal areas, and you'll say, the process in class today is what's called inductive logic. It begins with your problem. Find the centroid of a quadrilateral. You will then take what you know and what you've learned. It's a couple things we've talked about. You know things about equal area. You know that medians are made up of midpoints. And there are a number of things you're going to bring to the table. You're going to sit down in sketchpad and create what you think is the centroid.
You found the centroid when all the areas are equal.
Right.
So I'm just trying to figure it out.
Use the same concept. So you're saying maybe if I can divide this up into pieces that would put the same 4 areas, but
Yeah.
you're finding out that
So I was just about to delete it.
well, that's okay. I think that's definitely part of the concept, right? Is that
Yeah.
areas dealt with medians, centroids, and this is still going to be a centroid, but of a larger shape. It's got the hole in it. Oh, you should be okay. Try that again. Show a little faith there, Johanna. Feeling a little heavy.
I think it's too big.
You need some tape, maybe?
Yes, I'll try to save it and it'll work.
I think, but you can feel it, can't you? When you're putting that down, you can feel the weight being pulled down, isn't it? It's not going to go on. Let me see what you tried.